Have you ever wondered how scientists determine the composition of distant stars or diagnose diseases without invasive procedures? The answer lies in the fascinating world of spectroscopy. Spectroscopy is a scientific technique that allows us to study matter by observing the interaction of light with substances. It's like a secret decoder ring, unlocking the mysteries of the universe around us. Its importance spans across various fields, from astronomy, where it's used to decipher the composition and movement of celestial bodies, to medicine, where it aids in diagnosing diseases, and to chemistry, where it helps understand the structure and properties of elements and compounds. Spectroscopy is a broad field with different types, each offering unique insights. These include emission spectroscopy, absorption spectroscopy, and scattering spectroscopy, among others. So, we can say that spectroscopy is our window into the unseen world, revealing information that would otherwise remain hidden. Now that we know what spectroscopy is, let's delve deeper into one of its types: scattering spectroscopy. Scattering spectroscopy is a unique branch of spectroscopy that explores how light interacts with matter. Unlike absorption or emission spectroscopy, which deals with light absorbed or emitted by atoms or molecules, scattering spectroscopy is all about the scattering of light. It's a fascinating field that opens up a whole new way to investigate the properties of materials, from their molecular structure to their chemical composition. You see, when light hits a particle, it doesn't just go straight through or bounce back, it scatters. This scattering can tell us a lot about the particle itself. There are three main types of scattering that we consider in spectroscopy: Rayleigh, Mie, and Raman scattering. Let's begin with Rayleigh scattering. This occurs when the particles are much smaller than the wavelength of light. It's the reason why the sky appears blue to us on a clear day. The shorter blue wavelengths of sunlight are scattered more than the longer red wavelengths as they interact with the tiny oxygen and nitrogen molecules in the atmosphere. Next up, we have Mie scattering. This happens when the particles are about the same size as the wavelength of light. Mie scattering is responsible for the white appearance of clouds. The water droplets in the clouds scatter all wavelengths of light equally, giving us that familiar white, fluffy look. And finally, there's Raman scattering. This is a little different. It involves a change in energy of the light particles, or photons, leading to a change in their wavelength. This can provide us with detailed information about the vibrational modes of molecules, helping us to identify different materials. So, while all types of spectroscopy give us information about the interaction of light with matter, scattering spectroscopy allows us to look at this interaction from a different angle. It's a bit like having a new set of eyes to see the world in a different light. Scattering spectroscopy, therefore, provides a unique way to study the properties of materials, even at a distance. From the vast cosmos to the tiny particles in a liquid, scattering spectroscopy has a wide range of applications. One such application is Nepheloturbidimetry. Let's dive into the world of Nepheloturbidimetry. This fascinating term may sound a bit intimidating, but it's really not that complex. Nepheloturbidimetry is a sub-branch of scattering spectroscopy, which is all about studying how particles scatter light. In Nepheloturbidimetry, we are particularly interested in how particles in a liquid scatter light. Imagine shining a beam of light into a glass of water. If the water is perfectly clear, the light will pass through, virtually unaltered. But if there are particles in the water, they'll scatter the light in different directions. This scattering is what Nepheloturbidimetry measures. So how does it work? Well, the principle behind Nepheloturbidimetry is simple. A beam of light is passed through a liquid sample. If the sample is clear, most of the light will pass straight through. But if the sample contains particles, the light will be scattered. By measuring the amount of light that is scattered, we can determine the concentration of particles in the sample. Now, you may be wondering, why is this important? The answer lies in the name Nepheloturbidimetry itself. The term nephelo comes from the Greek word for cloud, and turbidimetry refers to the measurement of turbidity or cloudiness. So, Nepheloturbidimetry is essentially a method for measuring the cloudiness of a solution. This cloudiness or turbidity can tell us a lot about the sample. For instance, it can indicate the presence of impurities, or it can provide information about the size and nature of the particles in the sample. This makes Nepheloturbidimetry an invaluable tool in many scientific and industrial fields. Nepheloturbidimetry, in essence, gives us a way to measure turbidity or cloudiness in a solution, proving vital in many scientific and industrial applications. So next time you see a cloudy solution, remember, there's a whole world of science hidden in that turbidity. The effectiveness of nepheloturbidimetry depends largely on its instrumentation. Let's take a closer look at how it works. A nephelometer, the instrument at the heart of nepheloturbidimetry, is ingeniously designed to measure the intensity of scattered light. This is achieved through a few key components. Firstly, the light source. In most nephelometers, this is a laser beam. The laser beam is directed towards the sample, which is typically a suspension or a colloidal solution. The particles in the sample scatter the incoming light in all directions. This is where the second key component comes in, the photodetector. The photodetector is strategically placed at a particular angle from the incident light. This angle is usually 90 degrees, but it can vary depending on the specific requirements of the experiment. This angle is crucial because the intensity of the scattered light is not uniform in all directions. It's at its highest at a 90-degree angle from the light source, and it gradually reduces as the angle increases or decreases from this point. By measuring the intensity of the light at this particular angle, the nephelometer can accurately determine the amount of light being scattered by the particles in the sample. The scattered light then reaches the third key component, the optical filter. This filter is designed to allow only a specific wavelength of light to pass through, eliminating any unwanted light and ensuring the accuracy of the measurements. Finally, the scattered light, now filtered, reaches the photodetector. The photodetector converts the light into an electrical signal, which can then be processed and interpreted. Each of these components plays a crucial role in the functioning of a nephelometer. They work together to accurately measure the intensity of scattered light, providing valuable data about the particles in the sample. With the right instruments, nepheloturbidimetry becomes a powerful tool in the hands of scientists and researchers. Now that we understand how nepheloturbidimetry works, let's explore some of its key applications. Nepheloturbidimetry is a versatile tool with a wide range of applications in various fields. One of the primary applications is in environmental science, where it's used to measure the turbidity or cloudiness of water. By shining a light through a water sample and measuring the intensity of the scattered light, scientists can determine the amount of suspended particles in the water. This is crucial in assessing the health of aquatic ecosystems and ensuring the purity of our drinking water. Another significant application of nepheloturbidimetry is in the pharmaceutical industry. It's used to monitor the quality of drug suspensions, solutions, and emulsions. For instance, it can be used to measure the particle size and concentration in drug suspensions, ensuring that the formulation is accurate and safe for consumption. Moreover, it can also be employed to test the clarity of solutions and the stability of emulsions, which are key factors in determining the quality and effectiveness of medicines. Nepheloturbidimetry also finds application in the food industry, where it's used to assess the quality of beverages and liquid food products. For example, it can measure the turbidity of fruit juices, providing an indication of the juice's freshness and quality. It can also be used to monitor the stability of emulsions in products like salad dressings and mayonnaise, ensuring they maintain a consistent and desirable texture. In addition to these, nepheloturbidimetry can also be used in industries like brewing and cosmetics, and in research fields such as nanotechnology and colloidal science. It's the versatility and accuracy of this technique that make it such a valuable tool across different sectors. So, whether it's checking the clarity of a glass of water, ensuring the quality of your medication, or maintaining the consistency of your salad dressing, nepheloturbidimetry is working behind the scenes, playing a crucial role in our daily lives. From ensuring the purity of our drinking water to testing the quality of pharmaceuticals, nepheloturbidimetry plays a crucial role in our daily lives. To sum it up, spectroscopy, and more specifically scattering spectroscopy and nepheloturbidimetry, are critical scientific techniques with far-reaching applications. These techniques allow us to delve into the mysteries of the universe, from the composition of distant stars to the intricate details of complex molecules. Scattering spectroscopy, a branch of spectroscopy, uses the scattering of light to study the properties of materials, while Nepheloturbidimetry leverages the scattering of light to measure the turbidity or cloudiness of a solution. The principle of Nepheloturbidimetry is quite fascinating. It's all about how particles scatter light in different directions and how we can measure it. The instrumentation involved in Nepheloturbidimetry is sophisticated yet elegantly simple, comprising a light source, a sample holder, and a detector. The applications of Nepheloturbidimetry are diverse and significant, from environmental monitoring to clinical diagnostics. Spectroscopy unravels the mysteries of the universe and improves our daily lives in ways we often don't realize. Subscribe for more because you won't find me later.